going over your test review for your test on Chapter 8. Now, starting off the review, it says number 1, it says the production of a slightly soluble solid compound in a double replacement reaction results in the formation of and it should be B, precipitate. Now, that precipitate, remember, it's when a solid falls out of solution, so if it's only slightly soluble or if it's not soluble at all, it's going to form that solid and it falls out of solution. That's a precipitate. Now, number 2, it says to balance a chemical equation, it is permissible to adjust the. Anytime we're adjusting the coefficients, that's how we balance a chemical equation. So the answer would be A. We adjust those coefficients to the numbers in front of the formulas. Number 3, in a chemical reaction with the symbol AQ, it indicates that the substance means aqueous, it is dissolved in water. Okay, so the answer would be B. And 4, it says the tendency for a replacement reaction to occur increases. And we're looking here, anytime we're dealing with a replacement reaction, single replacement reaction, we're looking at the activity series. And the answer is going to be D. And because it says intervals between any two elements in the activity series increases, meaning they get farther apart from each other. The farther apart they are on the activity series, the more likely they are to replace each other. Okay, moving on to number 5, it says that the coefficient in a chemical equation, and the answer should be A, which is it indicates the number of moles of each substance in the reaction. What it means is with the coefficient, after we balance it, it gives us the ratio or the mole value for each of them. So if there's a 1 in front of it, that means there's only 1 mole or 1 part of that substance in the reaction. If there's a 2, there's 2 parts. Number 6, it says if metal X is lower than metal Y in the activity series, then, and the answer should be B, Y will replace X in the solution. So we know that Y would be on top because X is lower, so anything on top can replace anything below it. Number 7, in a reaction, the ions of 2 compounds exchange places in aqueous solution to form 2 new compounds. This is called A, and the correct answer should be D, double replacement reaction. So we have 2 compounds and their ions change places. So anything that starts with a compound plus a compound is always going to be a double replacement reaction. In number 8, it says the use of the double arrow in a chemical equation indicates that the reaction is, and the correct answer is A. So if we see this in a chemical equation, it is a reversible reaction. Okay guys, moving on to number 9. It says a small whole number that appears in front of the formula in a chemical equation is called A, and it should be coefficient. Remember that coefficients appear in front of the formula. So those are the numbers in front of formulas. Those are the coefficients. That's how we balance chemical equations. Number 10, it says in a chemical equation, the symbol L indicates that the substance is a liquid. 11, it says a chemical reaction in which the product reform the original reactants is it should be a reversible reaction. Okay, so in a reaction, if we can make the products and then we can reform the reactants, it's reversible. It goes back and forth. Remember, that's indicated by the double arrow. Number 12 says the general equation for a synthesis reaction. We get these from the PowerPoint notes we went over. Remember that if we start with 2 elements, so in this case A and X, it'll produce or combine or synthesize to AX. Now, a decomposition reaction, we're starting with a single compound, which is AX, which produces A plus X. Remember that this, in a synthesis, element. In a decomp, we're starting with 1 compound. In a single replacement, we're starting with an element plus a compound. So A plus BX produces B plus AX. We see that A and B switch places. So an element plus a compound produces an element plus a compound. And then lastly, for our double replacement reaction, we have AX plus BY. So it's a compound plus a compound produces a Y plus BX. And we see that A and B switch partners. Remember guys that when we start in a synthesis, we're starting with an element plus an element. In a decomposition, we're starting with a compound. In a single replacement, it's element plus compound. In a double replacement, it's compound plus compound. Okay, guys, moving on to 17. It says a chemical reaction in which a substance combines with oxygen releases a large amount of energy and heat and light. This is a combustion reaction. The main thing that I want you to know about a combustion reaction is basically that it has the products of carbon dioxide and water. Okay, main thing we need to know is just the products are carbon dioxide and water. Okay, moving on to 18, it says the decomposition of a substance by electrical current is called, and that would be electrolysis. We did this, or we watched this when we did the electrolysis of water. Meaning we took H2O, put electricity through it, and produced hydrogen and oxygen. All right. Number 19, a list of elements ordered by the ease with which they undergo certain chemical reactions. This would be the activity series. Remember that it goes from the most active on the top to the least active on the bottom. And remember that metals replace metals and non-metals replace non-metals. Moving on to number 20, it says the names and relative amounts of reactions and products in a chemical reaction are represented using symbols and formulas in the chemical equation. 21 says the law of conservation of mass and energy must be satisfied for chemical equations to be balanced. Remember, we have to have the same number of each atoms on each side. And that satisfies the law of conservation of mass and energy. Now, 22 says a blank product is sometimes indicated by an arrow pointing upward. We would indicate it with a G, and that would be a gas. And then finally, 23. It says the symbol with delta, or the triangle, means that the reactants are, and that should be heated. We add heat to that reaction. Okay, moving on to number 24 and number 25. Number 24 says, how are word equations and formula equations alike, and how are they different from a chemical equation? Now, a word equation, remember, it just uses the words to tell us what is going on. It doesn't actually give us the formulas. Now, in a formula equation, it gives us the formulas, but it's not balanced. Okay, they really just tell us what's going on, but they really don't give us any quantitative information about them. They don't give us the numbers. So a word equation uses the words, formula equations uses formulas. They're alike in that they give us qualitative information, but really main thing here, remember that word equations use the words to express it out. 25, it says, what are the three observations that indicate a chemical change may be taking place? Remember that those are going to be heat and light, production of a gas, or formation of precipitate. We can also throw in there changing color. We can also put that in there as well. Okay, guys, 26 and 27, the question wants to know, write a word equation for each chemical reaction in the space provided. So here we have our chemical equation, and now we want to write a word equation for it. So we're going from the symbol to the word. Here we have zinc sulfide, which is an ionic compound, so therefore we just name it as zinc, and then sulfur would be sulfide, so zinc sulfide. We have oxygen all by itself, so it would just be oxygen. And it produces, which in a word equation we would just have zinc sulfide plus oxygen with the arrow. It produces our zinc oxide, because this is ionic. We have zinc and oxygen. And then here we have a covalent compound, so we need to put prefixes, and we have sulfur dioxide. Moving on to the next one. Here we see that we have sodium and iodine. It's an ionic equation, so it's just sodium iodide. We have chlorine all by itself, so it's just chlorine. And then we have sodium and chlorine together, which they're an ionic compound, so that would be sodium chloride, plus iodine all by itself, so it's just iodine. So we have sodium iodide plus chlorine. It reacts and produces sodium chloride and iodine. Okay, guys, here on 28 and 29, it says write the formula equation for each word equation in the space provided. So here we're writing the formulas from the words. We see that we have magnesium plus oxygen, and it produces magnesium oxide. So we have magnesium, which is just Mg. We write it with an element by itself, and then oxygen as an O. Anytime we write an element, we always have to check, is it a part of Brinkelhoff? Is it a diatomic? Because if it is, then it gets a subscript of 2. And remember that magnesium is not, and oxygen is, so we go O2. So that would be a 2 right there. And then we have magnesium oxide. Anytime we write a compound, we have to crisscross. So we'll have magnesium, which is Mg, bonding to oxygen, which is O. Magnesium has a +2 oxidation number because it's in group 2. And oxygen has a -2 because it's in group 16. So we crisscross and we get Mg2O2, which reduces down to MgO. Now it doesn't ask us to balance it, so we're not going to balance it here. Next one, we have calcium carbonate, and it produces calcium oxide and carbon dioxide. So calcium carbonate is a compound, so we need a crisscross. So we have calcium, which is Ca, carbonate, which is CO3. Calcium has a +2 oxidation number, and carbonate has a -2. So we crisscross these guys, and we get Ca, parentheses, CO3, 2. Oh, I forgot my 2 over here. And we see that that 2 and that 2 will reduce, and we'll just have calcium carbonate, Ca, CO3. Now it decomposes into calcium oxide, which we have calcium, which is Ca, and oxygen. Calcium, which is +2, oxygen, which is -2. And we crisscross and we get Ca2O2, which reduces to CaO. And then we have carbon dioxide, and we don't crisscross here because we see a prefix, so it's just carbon, 1, and dioxide means 2 oxygens. And there we would have our formula equation. Okay guys, let's move on to 30 through 33. It says on the line to the left, identify each equation as a synthesis, decomposition, single replacement, or double replacement reaction. Guys, just a refresher on what we need to know about these guys. We can recognize them by the reactants. We know that in a synthesis reaction, we have an element plus an element. In a decomposition, our reactant is just going to be one single compound. In a single replacement, we're going to deal with an element plus a compound. And in a double replacement, we're dealing with a compound plus a compound. So let's go ahead and identify these guys. Starting off at the very top, we see that we just have water as our reactant, so we just have one compound. So we know that that is going to be a decomposition reaction. Number 31, we see that we have chlorine plus potassium bromide. Okay, so we have an element in chlorine, and then we have potassium bromide, which is a compound, so an element plus a compound is going to be a single replacement reaction. Now here we have a calcium oxide plus water, and those are compounds and compounds. Now at first we should think that, man, it's a double replacement reaction, but this is kind of one of those exceptions that we have to look at. We look and see that our reactants are both compounds and compounds, but our product is one single compound. So we see that we took two things and made it into one thing. So this is one way that this rule doesn't work, and we just have to make that a synthesis reaction. And then lastly, we have a compound in hydrochloric acid, a compound in sodium hydroxide. Compound plus a compound makes a double replacement reaction. All right, guys, on 34, it's wanting us to balance the following equation. So starting off here, we see that we have silver nitrate and copper 2 chloride produce silver chloride and copper 2 nitrate. So starting off, we're going to have silver as Ag. Nitrate we're going to keep as a polyatomic because we see it on both sides. And then we have copper, and then we have chlorine. Okay, so we're going to go ahead, write what we have on the reactants and the products. Remember, we're looking at the subscript, so we have silver is 1, nitrate is 1, copper is 1, and chlorine is 2. On our product side, we see that we produce 1 silver, 1 chlorine, 1 copper, and 2 nitrates. So to balance this guy out, we need to balance our nitrates. Start there first. Put a 2 coefficient that distributes to the silver, makes silver 2, also makes our nitrate 2. So now we need to balance our silver on the other side, so we'll put a 2 in front of that, and we get a 2 for our silver and a 2 for our chlorine. So this would be our balanced equation. Okay, on 35, we're doing basically the same thing. We have lead 4 oxide, and we have our lead 2 oxide, and then oxygen. So here what we're going to do is we have lead, which is Pb, and oxygen, which is O. And on the reactant side, we have 1 lead, 2 oxygens. On the product side, we have 1 lead, and then we have 3 oxygens. So the first thing we need to do is make this 3 even. So we're going to put a 2 right here, which changes our lead to a 2, and it changes our oxygen now to a 4. And we can balance this out over here. We need to put a 2 in front of that to make our lead 2, and now our oxygen would be a 4, which this would be our balanced equation. Okay guys, moving on to 36. Here we see we have zinc. We're going to break this up into hydrogen and into oxygen. And we see that we have oxygen and hydrogen. And then here we have CH3COO. That is acetate. So we're going to keep it as acetate, and we'll just write it as C2H3O2 to save a little space. And that would be it. So we have 1 zinc. We have 2 oxygens, because that 2 will distribute. And then we have 2 plus the 1 will give us 3 hydrogens, and then just 1 acetate. Now in our products, we see that we have 1 zinc, we have 2 acetates, and we have 2 hydrogens, and we have 1 oxygen. Okay, so to balance this out, we need to put acetate. We need 2 of those, so we will put a 2 coefficient in front of our acetate, which gives us a 2 right here, and that means acetate is going to be 2. But it also changes our hydrogen. Now we have 2 here and 2 there. It's going to go to a 4. So the only thing left to balance is our hydrogen and oxygens. To do that, we'll put a 2 coefficient there, which gives us 4 hydrogens and now 2 oxygens. And now we have a balanced equation. Alright guys, here it's wanting us to figure out, will these reactions happen? And if they will happen, we need to write the products and balance it. So looking at whether something is going to happen, we have our single replacement reaction. We're going to use our activity series over here. And here we have magnesium. It's reacting with steam, which steam is H2O. We can rewrite H2O as HOH. Because here it's going to be a compound. What we're going to see is a single replacement reaction. So magnesium is going to try to replace hydrogen. So we check and we see that there's magnesium, hydrogen's way down here, so the reaction will happen. So we need to go ahead and write out the products. So magnesium is now going to be bonded to hydroxide. So it's Mg, now bonded to OH. So we have a +2 and a -1. We crisscross and we get MgOH2. And our other product is going to be hydrogen. Now hydrogen's written by itself, it's a diatomic, so we put a 2. Now we have to check and see, is it balanced? So on this other side, we're dealing with our magnesium, hydrogen, and oxygen. In our reactants, we see that we have 1 magnesium, we have 2 hydrogens, and 1 oxygen. In our product side, we see that we have that 2 will distribute to the oxygen and to the hydrogen. So we have 1 magnesium, 2 oxygens, and we see we have 2 plus 2 is 4 hydrogens. So to balance this out, we got to make our hydrogens 4, so we'll put a 2 right here, which changed our hydrogen to a 4 and our oxygen to a 2. So this would be our balanced equation. Okay, moving on to 39. So here we're looking and seeing if the reaction can happen, and if it can, write it out. So in dealing with this, we're looking at it and we see that we have chlorine and magnesium bromide. So chlorine is going to, since it's a nonmetal, it's going to try to replace bromine. And since chlorine is above bromine on the activity series, it will happen. So now magnesium is going to be bonded to chlorine, and bromine is going to be by itself. So I write bromine as Br, and I write 2 because it's the diatomic. And then we have magnesium bonded to chlorine. Magnesium is Mg, which is +2, and chlorine is Cl, which is -1. Crisscross these guys and we get MgCl2. Okay, now we have to balance it. So we have magnesium, we have bromine, and we have chlorine. And we see that in the reactants we have 1 magnesium, 2 bromines, 2 chlorines. Okay, in our products we see we have 1 magnesium, 2 bromines, and 2 chlorines. So this would already be balanced. Okay guys, here in 40 we have zinc and hydrochloric acid. So zinc is going to try to replace hydrogen. There's a metal and its hydrogen's acting as a metal. So we look over here and we find zinc. Zinc is right here. And then hydrogen is way down here. So zinc is on top, so the reaction will happen. So hydrogen will now be by itself, and we write H2 because it's a diatomic. And zinc's going to be bonded with chlorine. Remember, zinc always has a +2 oxidation number. And then chlorine's -1. Zinc, we just have to know and have that memorized. Guys, here I'll tell you that if you do want to use a note card on the test, you are more than welcome to. Stipulations that you have to do, or you will not be able to use it. Number 1, it has to be a 3x5 note card. Number 2, it has to be written. And number 3, you can only use one side of the note card. Okay, can't use both, got to use one. Guys, if you don't show up with those 3 things, you cannot use the note card. Don't make me be the bad guy. You got to have those 3 things. 3x5, got to be written, and got to be just using the front. Okay, so back to the problem. Let's go ahead and crisscross here. We have ZnCl2. So let's go ahead and balance this guy. We have zinc, we have hydrogen, and we have chlorine. And we see that we have 1 zinc, 1 hydrogen, 1 chlorine, and then on the product side, we have 1 zinc, 2 chlorines, and 2 hydrogens. So to balance this out, we need a 2 in front of this, which will make hydrogen go to a 2 and chlorine go to a 2, which that'll be our balanced chemical equation. Okay guys, working out number 42, we see that we have nickel, and it's trying to react with copper 2 chloride. So in this reaction, we're going to go ahead and nickel is going to try to replace copper because metals try to replace metals. So we look over here and we find that nickel is right here, and then we have copper, which is way down here. So nickel is on top, so this reaction will happen. And we see that we're going to have copper all by itself, so just Cu. And then our other product is going to be nickel bonded to chlorine. Now nickel has a +2 oxidation number, and chlorine has a -1 oxidation number. We crisscross these guys and we get nickel 2 chloride. Okay, from here we just got to go ahead and balance it, and we're going to go ahead and we see that we have 1 nickel, 1 copper, 1 copper, 2 chlorines, 2 chlorines, so it's already balanced. So this would be our answer. All right, moving on to 44, we see that we have magnesium, and it's trying to bond with copper, or not copper, but cobalt nitrate. Here, so we're going to look in magnesium's a metal. It's trying to replace a metal of cobalt. So looking at it, we see that we have magnesium, and magnesium is going to be right here. And then we have cobalt, and cobalt is down here. So magnesium is on top. This reaction does happen. So let's go ahead and make it happen. So we're going to have cobalt all by itself, so just CO. And then we're going to have it where magnesium is bonding now to nitrate. So we have magnesium, which is a +2 oxidation number, and then nitrate, which is NO3, which is a -1. And we crisscross these guys, and we get MgNO3 in parentheses, and then 2. Okay, so we go ahead and check and see if it's balanced. We have 1 magnesium, 1 cobalt, 1 cobalt, 2 nitrates, 2 nitrates. So this is a balanced chemical equation, and this would be your answer. All right, guys, that's it for the review. If you have any more questions, please come in and ask me in the morning. Good luck.